What is up, Algebra 2? Grab your popcorn. It's time to crush this Unit 4 review. We're going to start with the yellow paper, so make sure you have the yellow paper out. We'll do the white packet after this. But the very first one, it says, which graph above illustrates indirect variation? And we know that indirect variation is y equals k divided by x. So if we look at our graphs here, we see this one, that straight up and down line. That's our good old y equals k times x. That's direct, so it's obviously not going to be A. It's either going to be C or B. They're both curved graphs. But if we look at both B and C, this one has our asymptotes right at 0. This one, we can tell that it's been shifted over to the left. So since that's been shifted over, it means that that's y equals k over x, and then some sort of plus h down here because it's moved over. So that means that that one is not your regular indirect variation. So our answer there is B, because it goes right around the origin there. Next one we're going to look at, number 2, decide if the data represents direct or inverse variation. The easiest way that we can do these is looking at both the x and the y to see if there's a pattern. So we can tell that as your y value increases, goes 2, 4, 16, 32, your x value is also increasing. If both your x and y are increasing, that means that it's got to be a direct variation, so y equals k times x. Now we need to write the equation of the variation. So if I want to write the equation, we need to find what this k is first. So we need to take any y and x values. So in this case, I'll just use 1 and 4, and that's going to go where my y and x are here. So I've got 4 equals k times 1, because we just plugged in 1 and 4, and we know that the only thing that times 1 gives me 4, k has to be 4, because 4 times 1 equals 4. So then for our answer there, we just need to put that k back into our equation. So we end up with y equals 4 times x, and there's my answer for that. By the way, if you need to pause at any time here to catch up, feel free to. Number 3, we got the time t. I'm going to go ahead and underline t because that's going to be important. The time t required for a bus to travel a certain distance varies inversely. There's our magical words, varies inversely, as its average speed r. So there's our other important letter. It takes the bus 2.2 hours to travel between the two cities at 50 miles per hour. How long would the same drive take at 40 miles per hour? This is a two-part problem, but the very first thing we need to notice is that varies inversely. That tells you exactly what equation to use. And we know that inverse variation is going to be my y equals k over x. But instead of y varies inversely as x in this case, we have t varies inversely as r. So instead of y equals k over x, we've got t equals k over r. And the easiest way to tell that is it's whatever letter comes first is going to be on the left side of your equation there. Now if we take the numbers that they're giving us, it says it takes the bus 2.2 hours to travel between the two cities at 50 miles per hour. Well, we've got our time there. Our time is 2.2. So we'll say 2.2 hours equals k divided by r. Our rate would be 50 miles per hour. So if I want to find what k is, we multiply both sides by 50, and we end up with k equals 110. Now, like I said, this is a two-part problem, so we found k first, but now we just need to take this k and put it back into my equation to find what our new time would be at 40 miles per hour. So I'm going to go ahead and set this equation up now. We've got t equals k, which is my 110, and then my new r value here is going to be 40 miles per hour. And so 110 divided by 40 gives me my new t equals to 2.75 hours. All right. Rolling along. This one says solve using a table or a graph. I'm just going to go ahead and solve it algebraically since I don't have a table or a graph with me. But anytime it says solve, the only thing it's wanting us to do is find this x value right here. So what we need to do is try to get that x value by itself. In this case, we've got this denominator 2x. In order to get that denominator out of there, I need to do the opposite of what's going on here. So we see we've got a division sign there, so I'm going to multiply both sides by 2x. Whenever we do that, these two x's are going to cancel out here, and now I'm left with x minus 4 equals 4x, because that 2 times 2 gives me 4x. And so now, whenever we move the x's to one side and leave the numbers on the other side, we know that we can do minus x, and I get negative 4 equals 3x. Now remember, we want to find what x is, so now we just get that 3 away from it, so I divide 3 to both sides, and I get x equals negative 4 thirds. You can always check these answers. Now, we said x equals negative 4 thirds, so it makes sense that if we plugged it back into my equation, negative 4 thirds minus 4 divided by 2 times negative 4 thirds should give me 2, and go ahead and check that on your calculator if you'd like to. Now we're going to shimmy down to number 5, indicate the asymptotes, domain, and range. So if we look at this, the big thing that matters here is that 1 over x. And if we have something, if we have y equals 1 over x, go ahead and take a second and graph that on your calculator. Go to your y equals and put in 1 over x. What you'll see is, here's your graph here. You'll see a graph that kind of does this, and as those lines get close to 0, they kind of curve sharply away from it. It looks super ugly. That looks better. Okay, but they'll curve sharply away from it. And so if we remember our transformations, we need to basically look to see what this plus 4 and this plus 5 do. So in this graph right here, if we started with horizontal asymptote, my horizontal asymptote right here is at y equals 0, because all of the y values along this are 0. Now, if we take this plus 5 here, it basically means we're taking our whole graph and we're just moving it up by 5. So if we go up 5, my horizontal asymptote now is at y equals 5. Very similar thing with the vertical asymptote. My vertical asymptote to start with is right here at x equals 0. But whenever we have this plus 4 here, it's going to move my graph to the left 4. So instead of having a vertical asymptote at x equals 0 now, my graph moves left over here and it would be at x equals negative 4. So my vertical asymptote, x equals negative 4. Now we're going to talk about domain and range before the test, so don't worry about those right now. Go ahead and try it. Think about which values are excluded for your domain and range now. But let's shimmy on over to number 6. It tells us we're going to subtract. We know that we've got these two fractions here. Doesn't matter what kind of fraction it is, if it's super complicated or really easy. We always need to make sure that these denominators are the same. We need a least common denominator in order to subtract or add any fraction. It also says identify any x values for which the expression is undefined. We will find that at the end of this. But if we look at this, we want to get these denominators to be the same. And in order to do that, we need to factor this right side to make it a little bit easier on us. So if we think about the numbers that multiply to give us 36 and add to give me negative 13, the only ones that would work there, if you think about a factor tree, you've got 1 and 36. That doesn't add up to negative 13. You've got 2 and 18. That doesn't do it either. And then you go through several of them until you figure out that your magical numbers are going to be 4 and 9. Now 4 and 9 add to give you positive 13, so we need them to be negative 13. So if I put a negative in front of both of these, negative 4 times negative 9 gives me negative 30, or gives me positive 36, and they add up to negative 13. So now my new equation, if I rewrote it, I've got 7 over x minus 9, and then minus 2x minus 6 stays up there, except now we take our two factors as x minus 4 and x minus 9. Now, like I said, we need to make sure our denominators are the same. But if we take a look at it, this one has x minus 9, but this one has x minus 9 and x minus 4. So what we need to do is multiply this side over here also by an x minus 4. But we need to do it to top and bottom to keep the fraction the same. So now if we simplify this a little bit, we've got 7 times x, which gives me my 7x, and then 7 times negative 4, which gives me negative 28. And my denominators are the same. We don't need to mess with those. My right side is going to be my minus 2x minus 6, and then x minus 4, x minus 9. So now whenever we go to subtract them, the only tricky thing here is going to be that negative sign, because we're not just saying minus 2x, we're saying minus 2x and minus negative 6. So whenever we combine our numbers, we've got a 7x minus 2x, which means I'm going to have a 5x. And then we've got a negative 28 minus negative 6. Minus minus makes a positive, so negative 28 plus 6 is going to give me negative 22. And then I have my denominators x minus 4, x minus 9. So there's my answer. They're all subtracted now. We've got my answer. And if we think about excluded values, going back up to the question, anytime that expression is undefined, it means that it's whenever we're dividing by 0, because we can't divide by 0. You can't take anything and divide it by 0. And the only numbers that would make this bottom 0 is if I had an x value of 4, because 4 minus 4 is 0, or an x value of 9, because 9 minus 9 is 0. So we'll say x cannot be 4 or 9. And that finishes up that problem. Then if we look right below it, we're going way back and multiplying exponents. So a little refresher on exponent rules here. We don't have any negative exponents, so we don't need to flip anything around. So what we're going to do is just do top times top and bottom times bottom, and then we'll simplify after that. So if we look at what we have here, we have a 4 times a 5, so we'll have 20. And then I've got an x2 and an x1, so if you think about that, x2 is basically x times x, and then x1 is just x. So if we multiply x2 and x1, we end up with x3 total on top. And then if you examine our y's, we have y to the 7th power times y to the 6th power. So if we have 7 y's and we multiply 6 y's with it, we're going to have a total of our 13 y's. And the very last one on top, z4 and z1 makes z5. And then on bottom, I've got 25, x7, y5, and z12. And z12. So now if we simplify that a little bit, we can simplify the 20 and the 25, the x's, the y's, and the z's, and our answer looks like this. Boom! 1y8 over 5x4 z7. Because 20 and 25, we can divide 5 out of both of them. 20 divided by 5 is 1. 25 divided by 5 is 5. And then looking at your exponents, think about which one's bigger. In this case, we've got x times x times x up top, and then we've got 7 x's on bottom. So if we take 3 out of the top and 3 out of the bottom, we're left with 4. And those same rules work for the y's and the z's. Now let's look on the back side. It just says solve. And remember, anytime you see the word solve, it just means figure out what x is. That's the only thing we don't know. So not only are we going to have to simplify it, we need to find what x is. In this case, we've got adding fractions on this side. And we know that anytime you add or subtract fractions, denominators have to be the same. So if we look at this, all my denominators look pretty different. But we can factor this one on the right here. And if I factor this 4x plus 4, I know that's really going to be 4 and then x plus 1 because we divide out the 4 there. So now if we think about that as a denominator, we've got a 4x plus 1 here. And then just an x plus 1. So this one is missing that 4. So we need to multiply that 4 on top and bottom there. And then my middle one is missing the x plus 1. So we need to multiply x plus 1. I'm going to kind of wedge that one in there. X plus 1 on top and bottom. And so now if you look at it, all of our denominators are the same, and that's what we want them to look like. So if we simplify it, now we got 4x over 4 times x plus 1 plus x times x gives you x squared, x times 1 gives you 1, so x squared plus x over 4x plus 1. And then the right side, we still got our 3 x over 4 times x plus 1. And so now if we simplify this left side over here, we can add these top pieces together since our bottoms are the same, and 4x plus x gives me 5x, and then the x squared there. And then now, since we've got the same denominators here, we can multiply both sides by 4 times x plus 1. And the beauty of that is now they divide out the tops and the bottoms. So now we're just left with whatever's on top there. So I have my 5x plus x squared equals 3x. Well, if we move the 3x to the other side, you get 2x plus x squared equals 0. And then the only tricky thing here is you just got to realize that you can factor out the x there. So if we take an x out, you're left with 2 plus x equals 0. And then divide both sides by x. And then we've got 2 plus x equals 0. Subtract 2 from both sides. X equals negative 2. And then remember, you can always plug this back into your question to check. You can take that and you can say 2 divided by, or negative 2 divided by negative 2 plus 1, and then make sure it all evens out. So let's take a look at number 9. We've seen a lot of these that have trinomials with x squareds in them. So hopefully you're used to factoring these by now. If we look at the top there, I need numbers that multiply to give me 15 and add to give me 8. The only things that would be x plus 3 and x plus 5. And on the very bottom, numbers that multiply to give me negative 40 and add to give me negative 3. It's a little bit harder to do this one in your head, so if you need to draw out a factor tree, you got 1 and 40, you got 2 and 20, 3 doesn't go into it, you got 4 and 10, 5 and 8. So, what kind of mutant 8 is that? 5 and 8. But we need negative 3, so one of these has to be negative because we also need to multiply them to get negative 40. And if we have a negative 8 and a 5, it gives us my magical negative 3 there. So we got x plus 5 and x minus 8. So if we think about what we can simplify out of there, those x plus 5s are going to divide out, and our answer is just x plus 3 over x minus 8. That's all that question wanted us to do. Number 10 here, we're going to solve. This one's a lot easier than the other one because we don't have to do anything fancy about the denominators. They're already the same. So what I'm going to do is just divide both sides by x plus 5. Multiply both sides by x plus 5, I'm sorry. And so whenever we do that, they're going to divide out tops and bottoms here, and you're left with 6x equals 2x minus 20. Put all of our x's on one side, so subtract 2x from both sides. You end up with 4x equals negative 20. Divide by 4, x equals negative 5. Next question. Number 11, identify the function of the graph below. Now there are several different ways you can solve this problem. The one that I'm going to focus on is using your horizontal asymptotes. So HA, horizontal asymptotes. If you remember our little trick to remember the different types of horizontal asymptotes, we've got BOBO, which means if your exponent is bigger on bottom, so for example if I had x over x cubed, it means you would have a horizontal asymptote at y equals 0, so that's what that 0 is. We have the botan. So if our exponent's bigger on top, so for example if we had x to the 4th over x1, then there would be no horizontal asymptote. So bigger on bottom is 0, bigger on top means none. And then the last one is if it sucks, SUC, if it has the same coefficient. So if it was like 2x squared over 4x squared, we'd use the coefficients, and in that case it would be y equals 2 over 4, or 1/2. So we look at our graph here. Obviously we have a horizontal asymptote, and it's not at 0. It's got to be at some sort of coefficient. So if I look at my answer choices here, my first one, that's going to be botan, bigger on top, which means none. But we definitely have a horizontal asymptote here, so that is not my answer. If we go down to B, I've got the same exponents, 2x and then x. They're both x to the 1. So my horizontal asymptote right there would be y equals 2, which looks like a possibility. But let's keep looking. Next one, I've got x2 over x. That's also a botan. We decided it's not going to be botan. And then x over 2x. Well, again, we've got the same, so my horizontal asymptote would be at y equals 1 over 2. But if we look at our graph there, we also have a vertical asymptote here. And then our only two possible answer choices, B and D. B would have a vertical asymptote at x equals negative 3, and D would have a vertical asymptote at 2. So this one obviously has a negative vertical asymptote here, so my answer choice has to be B. Now, what you can also do, if these get real tricky, is you can graph these on your calculator, make sure your window matches this, and see which one it looks most similar to. So, 100 ways to answer that one. Next one, going back to exponent rules. The harder things about this one is that squared part on the bottom. So the way that I like doing it is rewriting it. So the top still stays the same. But on the bottom, if you think about anything squared, for example, 3 squared is 3 times 3, so it's whatever that number is times itself. So in this case, we've got 6x negative 2y squared, so I'm going to have 6x negative 2y times 6x negative 2y. That's what that squared means, is just that thing times itself. So if we simplify that out now, you get the top stays the same, but the bottom, 6 times 6 gives you 36, x negative 2, x negative 2 gives you x negative 4, and then y squared. And the last thing that we need to do is move these negative exponents to the top and bottom, so that way they become positive. And my final answer is 1 over 9, because 4 and 36, 4 divided by 36 gives you 1 over 9. The y negative 3 goes to the bottom, the x negative 4 goes to the top, and we can combine them to get x9 and y5. The very last one, number 13. So we start with our 1 over x, and then we're doing some stuff to it here. We got reflecting across the x-axis, so we know we got a big negative out here. And then it says vertically compressed by a factor of 0.3, and that 0.3 is going to affect this number up top here. So now we've still got our negative there, but now we've got 0.3 up top. And then the last thing is translated down 2. So we know that down 2 is going to come out here. But you just got to make sure that that negative gets distributed to each piece. So you can either leave your answer like this, or you can write it as negative 0.3 over x plus 2, because it gets distributed to that 2 as well. So there's my final answer for that one. You can also graph this to double check to see if it makes sense. Now this will be the first video. I will make a second video for the white packet here. If you have any questions, you are more than welcome to come to tutoring on Thursday morning or Friday morning before your test.